All right, even and odd identities. So we've talked about even and odd before. Remember, even says it doesn't matter if you plug in the positive and negative of a number, you're going to get the same exact answer. So like with x squared, if I plug in negative 2, I get positive 4. If I plug in positive 2, I get positive 4. Therefore, x squared was an even function. And so we've talked about this before, where our only even function is going to be cosine and its reciprocal. So that means if you have cosine of negative x, that's the same exact thing as saying cosine of positive x. Secant of negative x is the same exact thing as saying secant of positive x. Now, if cosine is reciprocal to the only even, that means the other ones must be odd. Remember, an odd function is like x cubed, okay? Means when I plug in the positive or negative of a number, I'm going to get the same digit but the opposite sign. So like if I took x cubed and I plug in negative 2, I'm going to get negative 8. If I plugged in positive 2, I would get positive 8. So they both have an 8 in it, but one of them's negative, one of them's positive. So same digit, opposite sign. So if you have sine of negative x, it's going to get you the same exact answer as sine of positive x, but it's going to be the opposite sign. So we're going to say negative sine of x. And so cosecant of negative x gives you the same digit as cosecant of x, but the opposite sign. Same thing with tangent of x. So it's going to be the negative tangent of x. And cotangent of negative x would be negative cotangent of the positive x. All right, so example 7 says if sine of theta is equal to 1/2, find sine of negative theta. Well, remember, we know that sine of negative theta then, because sine is odd, that's equal to the opposite sign, but the same digit as sine of positive theta, right? So we know it's negative, but we know what sine of theta is. They told us sine of theta is 1/2. And so we get the opposite of positive 1/2, which is our negative 1/2 right there. Same digit, they both gave us a 1/2. One's positive, one's negative because sine is odd. All right, then 8. 8 changes it up a little bit here. It says find all the values of x in the interval from 0 to 2 pi that solve the fact that cosecant cubed of x over sine of x is equal to cotangent of x. And so they give us a technique here. They're kind of reminding us of the steps to go through, okay? So the first thing they want us to do is consider any domain restrictions. Well, remember, the domain restriction here is that we have a fraction. And so because we have a fraction, we know that our denominator cannot equal 0. So in this case, we know, I'm going to write it on the side here, that our denominator, the sine of x, cannot equal 0. Well, where is that at? Because we're actually solving this. That means we're going to get number answers, or we're going to get angle answers, okay? So where is sine of x equal to 0? Well, sine is my y is equal to 0 on my x-axis. So if you look at your unit circle, find where your y values are 0, you'll find it's at 0, and it's over at pi. Now, we're not going to say 2 pi because the 2 pi is not included, but it is in the same location as the 0 that's included. So that point is already taken care of. All right? So we know that our x here cannot be 0 or pi. So when we solve, if we get 0 or pi as our answers, we have to throw them out. They're not allowed because of the fraction at the beginning. All right. So now we just need to work on this. And they gave us a clue here. They said change everything to sine and cosine, just like I told you at the beginning, right? So we've got cosine cubed of x over sine of x equals cotangent of x. Well, cotangent, remember, is cosine over sine. All right? Then it says multiply both sides by sine to clear the fraction. So if we want to get rid of the fractions, remember we multiply by the denominator. So we could have also just cross-multiplied. We end up with the same answer at the end, okay? But when we multiply by sine of x, that cancels. Same thing here. And so we end up with cosine cubed of x equals cosine of x. Well, if you need to, guys, change this to just be x's. So this is the same as if I had x cubed equals x. What would we do? Well, I don't know anything to do with cosine cubed, so I'm really hoping I can factor. So in order to factor, I need to make sure this is set equal to 0. So I'm going to move this cosine of x over. And when I do that, I get cosine cubed of x minus cosine of x equals 0. And so I need to see now, can I factor? Well, cosine of x cubed minus cosine of x. Remember, the first thing we're going to do is greatest common factor. So do these two have anything in common? They both have a cosine of x in them, right? So I'm going to take out a cosine of x. Remember, when you take it out, that's when you divide it out. Cosine cubed divided by cosine is cosine squared. Minus cosine divided by cosine is 1. All right, let's see. Can I simplify this any more? It's up to you at this point, you know. Let's go with what we've got, okay? So we've got cosine of x can equal 0 because we've got these two being multiplied so we can separate them. And we got cosine squared of x minus 1 equals 0. Well, I can work on the first one. I can't do I can start looking for my angles in the first one, but my second one I need to solve for cosine still. So let's add the 1. So we have cosine squared of x equals 1. Take the square root to get rid of the square. So cosine of x equals, don't forget your plus or minus, the square root of 1 is 1. Alright, so cosine of x equals 0. This is kind of like what we did at the very beginning there where we found out what our x couldn't be. Now we need to find out what our x can be. So if cosine of x is 0, remember cosine is your x values on your unit circle. So x is 0 on the y-axis, so that would be at pi over 2 and at 3 pi over 2. Those are both good answers, okay? Those both work. Cosine of x equals positive or negative 1. Well, I'm going to split that up. So I'm going to look for where cosine of x is negative 1, and I'm going to look for where cosine of x is positive 1. Cosine is our x value. X is negative 1 at pi. But wait, up at the beginning we said x could not equal pi, so that's a bad answer. So we're going to throw it out. Cosine of x equals 1. Cosine is our x value. X is 1 over on the right where x equals 0. Again, it can't be 0, so we're going to throw it out. So it ended up pi over 2 and 3 pi over 2 are our only two solutions. All right, and nope, we got even, odd, and cofunctions. Sorry, I got ahead of myself there. All right, so cofunctions are complements of the same trig function. Namely, angles that are complements add to 90 degrees and have right trig ratios. Okay, so remember, complements are angles that add to 90 degrees. So they tell us if we got sine of pi over 2 minus theta, that's going to equal cosine of theta. And the reason is if I take pi over 2 minus theta and I add theta, I'm going to get pi over 2, which is 90 degrees. Okay? Secant of pi over 2 minus theta then will equal cosecant of theta. Tangent of pi over 2 minus theta will equal cotangent of theta. This is why we have the co-functions, is why they call it that, because it's matched with the one that sounds like it but has a co in front, okay? So, and then vice versa here. If I take cosine of pi over 2 minus theta, that's going to equal sine of theta. Cosecant of pi over 2 minus theta would equal secant of theta. And cotangent of pi over 2 minus theta will equal tangent of theta. So tangent and cotangent, secant and cosecant, sine and cosine are cofunctions if their angles are going to add together to equal 90, okay, or pi over 2. So let's try this. So example 9 says use cofunctions identities to find the following. If sine of theta is equal to negative 1/2, find cosine of theta over 2, pi over 2 minus theta. All right, so let's look. We know that cosine of pi over 2 minus theta is equal to sine of theta, correct? And we know from above that sine of theta is equal to negative 1/2. So we're able to switch it out, and we've solved for it already. B, we're going to have to think a little bit more here, okay? All right, so it wants us to find sine of theta minus pi over 2. Notice they switched it around on us, okay? So remember, though, if we had sine of pi over 2 minus theta, that would equal cosine of theta, correct? And so we know then from above that cosine of theta is equal to 0.38. So I'm going to switch that in. But these two are switched. They switched signs, which meant there has to do with the negative of it, okay? So sine of pi over 2 minus theta, well, let me try this. Let me back up a little bit on that one. So I'm going to take a break here, okay? So what we have, though, is sine of theta minus pi over 2. Notice the signs are different from what we have written above, which means I could rewrite this as sine of negative pi over 2 plus theta. Now remember, if you want both the signs of something to change, you can multiply it by -1 or you can divide it by -1. So this is the same thing as saying sine of negative and then pi over 2 minus theta. Now, if you remember back to your even and odd functions we just talked about, remember sine is an odd function, so sine of a negative angle is equal to the negative sine of that angle, isn't it? All right, so in that case we can come back up here then. I'm going to bring this over here. So we know that what we are after, that sine of theta minus pi over 2, is the same thing as negative sine of pi over 2 minus theta. And we just said the sine of pi over 2 minus theta right here was 0.38, so we're going to get negative, and that equals 0.38. So I had to use my cofunction identities and the fact that sine was odd in order to figure this one out. All right, and so that is the end of 5.1.